Nice. So we have analyzed everything about photosystems, and now we go into the actual process of light reaction, cyclic and non-cyclic photophosphorylations. If you remember, we just talked about it. In cyclic photophosphorylation, we will use PS1, P700. And in non-cyclic photophosphorylation, we will use both PS1 and PS2, that is P700 PS1 and PS2, that is P680. तो चलो analyze करते हैं what is cyclic and non-cyclic photophosphorylation. सबसे पहले, what is the meaning of photophosphorylation or light reaction? The synthesis of ATP from ADP and IP is called as phosphorylation. ADP plus IP using 7.3 kilocalories of energy is called as phosphorylation. When the ATP molecules are synthesized in chloroplast, making use of light energy, then that is called as photophosphorylation. तो क्लोरोप्लास्ट के अंदर ADP and IP using light, sunlight as a source of energy to form a molecule of ATP is called as photophosphorylation. So that is photophosphorylation, and it takes place in the grana of the chloroplast, in the thylakoid, in the quantosomes. Two types, namely cyclic photophosphorylation and non-cyclic photophosphorylation. Chalo, let's see what they are. Cyclic photophosphorylation, the principle, it involves photosystem 1 P700. P700 जिसके अंदर let's see the logic कि photosystem 1 के ऊपर जैसे ही light गिरती है, it releases electron, and that electron passes through a series of electron acceptors and returns back to the same photosystem. So chlorophyll A में से electron जाता है और घूम फिर के वापस electron आ जाता है. Hence the process is called as cyclic photophosphorylation. So here photosystem 1 P700, on receiving light energy, the electron is excited and released from the reaction center of PS1. PS1, in other words, chlorophyll A 700 में से electron निकल के जाता है. And chlorophyll A 700, on losing the electron, becomes excited. But do we remember, this excited chlorophyll A can remain excited for only 10 raised to minus 9 seconds, which means in 10 raised to minus 9 seconds, the electron will pass through a series of electron acceptor and return back to chlorophyll A 700. So chlorophyll A 700, on losing electron, had become chlorophyll A 700 plus. So on losing the electron, it becomes chlorophyll 700 plus. On gaining back its electron, it will come back to a ground state. Let's analyze that. So it will return back. Hence, the process is called as cyclic photophosphorylation. Let's understand this process now. Sir, जैसे ही light chlorophyll A के ऊपर गिरती है, light, as soon as it falls on photosystem 1, P700. What will happen? Light falls on photosystem 1, P700. तो ये है आपका क्लोरोप्लास्ट. क्लोरोप्लास्ट के अंदर light will pass through grana. From grana, it will pass into thylakoid, और thylakoid में quantosome, and quantosome में से what will happen? If you remember, this is P700. So chlorophyll A683, chlorophyll B, carotene, xanthophyll will all receive solar energy, and the electron will jump towards chlorophyll A molecule. And chlorophyll A700 at 700 nanometer wavelength will get excited by energy coming by resonance transfer, and this electron will jump from chlorophyll A. So chlorophyll A 700, which is the reaction center, chlorophyll A 700, which is the reaction center, on losing its electron. Chlorophyll A 700, the reaction center, on losing its electron, will become chlorophyll A 700 plus. Chlorophyll A 700 plus. It has lost its electron. This electron is first accepted by a molecule called Z. Z, also called as ferredoxine reducing substance. Ferredoxine reducing substance. From ferredoxine reducing substance, the electron will go to ferredoxine. So ferredoxine will accept electron. What is accepting electron called as? Reduction. So ferredoxine reducing substance will give away the electron and reduce ferredoxine. So it is rightly called as ferredoxine reducing substance. Now ferredoxine is electronegative, but ferredoxine is more electronegative. In other words, electron goes from, I hope you remember, lower redox potential to higher redox potential from FRSZ to ferredoxine. Ferredoxine से ज्यादा इलेक्ट्रोनेगेटिव, फेरिडॉक्सिन से ज्यादा इलेक्ट्रोनेगेटिव is cytochrome B6. Cytochrome B6 is more electronegative compared to ferredoxine. So electron will go from ferredoxine to cytochrome B6. And cytochrome B6, in other words, has got a higher redox potential than ferredoxine. And ferredoxine से ज्यादा redox potential cytochrome B6 का है. From cytochrome B6, the electron will now go to cytochrome F. From cytochrome F, the electron goes to plastocyanine, and plastocyanine से भी ज्यादा electronegative with a greater redox potential is chlorophyll A 700 plus. Chlorophyll A 700 plus has the highest affinity for electron. So plastocyanine से the electron will return back to chlorophyll A 700 plus, and on losing electron, it had gone into an excited state. But on gaining back the electron, chlorophyll A 700 plus will again become chlorophyll A 700. In other words, it will come back to the ground state. So where has the electron gone? From chlorophyll A 700, electron went to FRS Z, and chlorophyll A 700 became chlorophyll A 700 plus. क्योंकि एक इलेक्ट्रॉन कम हो गया. From FRS it went to ferridoxine. From ferridoxine it went to cytochrome B6. From cytochrome B6 it went to cytochrome F. From cytochrome F it went to plastocyanine. From plastocyanine it goes back to chlorophyll A 700, and chlorophyll A 700 on accepting the electron again becomes chlorophyll A 700. Chlorophyll A 700 plus again becomes chlorophyll A 700. So electron जाता है from PS1 और घूम फिर के वापस आ जाता है. Hence this process is called as a cyclic process. तो इलेक्ट्रॉन जाता है, घूम फिर के वापस आता है, तो इलेक्ट्रॉन गया ही क्यों? बिकॉज जब इलेक्ट्रॉन जाता है, it goes out with energy, and when it returns back it has lost its energy, so it is without energy. So when it goes out it is with energy, when it returns back it is without energy. So while passing from one electron acceptor to the other, the electron keeps on losing energy, and that energy gets trapped between ADP and IP to form a molecule of ATP. Let's see कहां ATP बनता है. When electron goes to Z, there is loss of energy. थोड़ी सी एनर्जी लूज होती है, but it is not sufficient to make an ATP. From Z to ferridoxine, again there is loss of energy, but not enough energy, means less than 7.3 kilocalories of energy, means उसमें भी ATP नहीं बनता है. But when electron goes from ferridoxine to cytochrome B6, this time electron loses energy greater than 7.3 kilocalories. Greater than 7.3 kilocalorie, and that means between ADP and IP, a high energy bond of 7.3 kilocalories is formed, and that generates a molecule of ATP. So एक ATP बनता है between ferridoxine and cytochrome B6. Between cytochrome B6 and cytochrome F, again the electron loses a lot of energy, and between ADP and IP, it forms a molecule of ATP. Then from cytochrome F to plastocyanine, अब तक majority energy निकल गई है. So now this electron releases less energy, and plastocyanine से chlorophyll A के अंदर जब इलेक्ट्रॉन आता है, very little energy is lost, and that is lost as heat energy. वो heat हो जाती है, and chlorophyll A 700 on losing electron had become chlorophyll A 700 plus. On gaining back its own electron, it again becomes chlorophyll A 700, and electron gaya with energy, lota without energy, this was with energy, and this is without energy, and while passing from one electron acceptor to the other, energy was dissipated, and थोड़ी थोड़ी एनर्जी हर स्टेप में लिबरेट हुई, उसमें 2 स्टेप में 7.3 किलो कैलोरी से ज्यादा एनर्जी लिबरेट हुई, और उन 2 स्टेप्स में between ADP and IP, a molecule of ATP was formed by trapping 7.3 kilocalorie of energy. कौन से 2 स्टेप में? ड्यूरिंग ट्रांसफर ऑफ इलेक्ट्रॉन फ्रॉम फेरिडॉक्सिन टू साइटोक्रोम B6 and during transfer of electron from cytochrome B6 to cytochrome F. तो फेरिडॉक्सिन टू साइटोक्रोम B6 और साइटोक्रोम B6 से साइटोक्रोम F, ये 2 स्टेप में एटीपी बनता है, और एटीपी बनता है तो एक नॉन साइक्लिक साइक्लिक प्रोसेस में 1 + 2 a total of 2 ATPs are formed. 2 ATPs are formed in one cyclic photophosphorylation. Where does this process take place? In PS1. Where was PS1 present? If you remember, on the outer membrane of the thylakoid and the intergranule lamellae. याद है कि नहीं? On the outer membrane of thylakoid and intergranule lamellae, intergranule lamellae में cyclic process होता है, and outer membrane of thylakoid में भी cyclic process हो सकता है. Now, cyclic takes place in intergranule lamellae. Now we have non-cyclic photophosphorylation. ये तो बहुत simple था. Now we have an interesting one. Non-cyclic photophosphorylation. Non-cyclic photophosphorylation involves both photosystems PS1, that is P700, and PS2, that is PS680. तो दोनों PS1 और PS2 इन्वॉल्व होते हैं. PS1 and PS2 दोनों इन्वॉल्व होते हैं. So when will this take place? This takes place inside the thylakoid. If you remember, PS2 is present on the inner membrane of the thylakoid. यहाँ पर PS2 है, और outer membrane of thylakoid में PS1 है. तो PS1 है, यहाँ PS1 है, तो inner membrane और outer membrane के बीच में होता है non-cyclic photophosphorylation. When does non-cyclic photophosphorylation take place? Between the outer membrane and the inner membrane of the thylakoid. हाँ, intergranule lamellae में PS1 तो होता है, but this is PS2, I'm sorry. So PS1 तो होता है, but PS2 नहीं होता है. Not in the intergranule lamellae. So intergranule lamellae, which have got PS1, participate only in cyclic photophosphorylation. So intergranule lamellae is only for cyclic, to produce ATP. And in the thylakoid, between PS2 and PS1, on the outer membrane PS1, on the inner membrane PS2, उनके बीच में होता है non-cyclic photophosphorylation. चलो, तो let's see what happens. In non-cyclic photophosphorylation, 3 चीजें होती है. There is formation of ATP, like cyclic, and energy-rich NADPH2. Hey, if you remember, respiration में energy-rich NADH2 होता है. Nicotinamide adenine dinucleotide, NAD, in mitochondria. Chloroplast में you have NADP, nicotinamide adenine dinucleotide phosphate. So in respiration, NAD becomes energy-rich NADH2. In photosynthesis, NADP NADP. Nicotinamide adenine dinucleotide phosphate becomes with energy rich NADPH2. तो दोनों में NAD involved है, but photosynthesis में it is NAD becoming NADH2, which is energy rich, and that is in respiration. And in photosynthesis, NADP becomes NADPH2, which is rich in energy. सबसे important, along with energy, ATP and NADPH2, दोनों में energy होती है. There is photolysis of water, light-induced breakdown of water and liberation of oxygen. तो ऑक्सीजन जो इवॉल्व होता है प्लांट्स में से, और वो ऑक्सीजन जो हम ह्यूमंस यूज करते हैं, ये ऑक्सीजन प्लांट्स में कौन से प्रोसेस में इवॉल्व होता है? ड्यूरिंग नॉन साइक्लिक फोटोफॉस्फोराइलेशन. तो थैंक गॉड प्लांट्स में नॉन साइक्लिक फोटोफॉस्फोराइलेशन होता है. उस प्रोसेस में there is liberation of oxygen which is used by all living organisms for the purpose of respiration. Breathing के लिए वो प्रोसेस में काम आता है. ध्यान से, non-cyclic photophosphorylation में there is release of high energy electrons from PS1, but these electrons do not return back to PS1. PS1 में से इलेक्ट्रॉन लिबरेट होते हैं, तो ये है नॉन साइक्लिक प्रोसेस. PS1 में से इलेक्ट्रॉन लिबरेट होते हैं, which is accepted by Z and then by ferredoxine. But from ferredoxine, you remember cyclic, it should go to cytochrome B6, cytochrome F, plastocyanine and return back to PS1. बट नॉन साइक्लिक प्रोसेस में नहीं, इलेक्ट्रॉन ऑफ PS1 जाता तो है Z के पास, Z से फेरिडॉक्सिन के पास, बट फेरिडॉक्सिन से it does not return back to PS1. PS1 पे इलेक्ट्रॉन वापस लौट के नहीं आता है. And as a matter of fact, another thing, PS2 also releases electron. And after passing through electron transport chain, it enters PS1. So PS2 also releases electron, which goes to plastoquinone, cytochrome B6, cytochrome F, plastocyanine. But electron वापस PS2 के पास नहीं आता है. तो PS2 का इलेक्ट्रॉन PS2 के पास नहीं आता है. PS2 का इलेक्ट्रॉन PS1 में चला जाता है. अरे बाप रे, तो इलेक्ट्रॉन कहां से कहां पास हुआ? इलेक्ट्रॉन वेंट फ्रॉम PS2 टू PS1 and PS1 से it was liberated away and was not returned back to PS1. So this process is a non-cyclic process, क्योंकि electrons are not returning back to their own photosystems. Electrons are not returning back to their own photosystems. So the process is non-cyclic photophosphorylation. चलिए, beautiful process, इसको समझते हैं. सबसे पहले what are the steps involved? तो सर ध्यान से, सबसे पहले how does this process take place? Just a second.